Hello again, everyone, and welcome to another video lecture for Psych 370. In this one, I'm going to say a little bit about two more topics that are covered in your reading assignment for this week, which are insight and creativity. So let's get right to it. I'll start with insight, which is covered on pages 176 through 180 of the textbook, and which has sometimes been said to be unexplainable in terms of operant conditioning. So it's sometimes been claimed that insight represents a categorically different way of solving a problem than what we can account for using principles like reinforcement. So, to understand why someone might say that, think back to how Thorndike's cats learned to escape from those puzzle boxes that Thorndike put them in. He described the strategy that those cats used as one that involved trial and error, right? Or trial and accidental success might be a better way to put it. So they'd try different things, seemingly at random, like scratching at the floor or pawing outside the box at the food, until eventually they just sort of happened upon the correct solution, like stepping on the lever here that would spring the latch and open the door. So they basically just stumble across the right thing to do at first, but then over the course of several more trials in the puzzle box, they gradually learned to associate that response, stepping on the lever, with the consequences of escaping from the box and eating the food. So Thorndike observed what he considered to be a very gradual process of the cats learning how to solve his puzzle boxes. But the thing is, even though humans and other animals often do use that sort of trial and error method to solve problems, we don't always seem to come up with solutions gradually like that. So sometimes the solution to a problem appears much more suddenly. And guys, that sudden appearance or that seemingly sudden appearance of the solution to a problem is what we're talking about when we talk about insight. So, insight is what we call it when we struggle with a problem for a while. We feel like we aren't getting any closer to solving it. And then, seemingly out of the blue, the solution hits us. We get this sudden realization of what the solution is, which is often described as an aha moment because it's like we suddenly go, aha, that's it. Okay, so that's called insight. And a classic example of insight, which is also described in your book, was reported by a psychologist named Wolfgang Kohler, who gave a chimpanzee named Sultan two hollow sticks, and then he put some fruit just far enough away from Sultan's cage that he couldn't reach it with either stick alone. So that was the problem that Kohler presented to Sultan. How is he going to get this fruit? And as Kohler describes it, Sultan tried for a while unsuccessfully to get the fruit. And then, after about an hour, he suddenly stopped. He sat down. He looked at these two sticks, and he seemed to realize all at once that he could just slide one stick into the other one to make one long stick that he could use to retrieve the fruit. So, if you haven't read yet about that and the other examples of insightful problem solving that are described in the textbook, then you definitely should. But as one more example of insight, also in a chimpanzee, I want to show you this video.
At the Max Planck Institute for Evolutionary Anthropology in Leipzig, Germany, psychologist Joseph Cole places a peanut inside a clear tube. How can the chimpanzee get the snack? She's never seen this puzzle before.
For 10 minutes, there is no solution inside. And all of a sudden, boom, they solve it. They have to understand that they can use the water as a tool. This is interesting because the water itself, it doesn't have any shape.
Using water as a tool seems like something we would do on a good day.
Okay? So sometimes solutions to problems do appear rather abruptly like that in what seems like a sudden flash of understanding. And so the question when it comes to insight isn't really whether such sudden realizations occur, but rather why they occur. Because some people have claimed that insight is entirely the product of these mysterious inner workings of the mind, right? The hocus pocus of the mind, as your textbook puts it, and that it's completely independent of an animal's previous learning experiences. So some people have argued that insight does not depend in any way on the animal's previous history of reinforcement. But scientific research on insight calls that idea into question. So, for example, take this experiment by Robert Epstein and his colleagues, which was done using pigeons as subjects and which is described on page 179 of the textbook. In this experiment, some pigeons were only taught to climb on top of a box that was directly underneath a toy banana and to peck at the banana. But with other pigeons, not only did they learn that climbing and pecking task, but they also learned to push a box to different locations in their cages. So the researchers would put this little green spot in random places on the floor of the cage, and to get the reinforcer, the pigeon would have to push the box to that spot. Okay? And it's important to note here that when they were getting trained on that box pushing task, the toy banana was absent from the cage. All right. So they weren't being trained to push the box toward the banana because the banana wasn't there. When they were being trained to push the box, they got reinforced for pushing it toward the little green spot, not toward a banana. So that's what Epstein and his colleagues did first. They gave these two groups of pigeons different learning histories. So some pigeons only learned to climb the box and peck the banana, whereas other pigeons also learned to push a box around their cages. And then, once that training had been completed, Epstein and his colleagues presented these pigeons with a problem that was very similar to one that Kohler had used with his chimps. So they hung the toy banana from the ceiling so that the pigeons couldn't reach it on their own. They placed the box somewhere else in the chamber where it wasn't right underneath the banana like it had been before. They put no little green spot on the floor, so that spot was there when some of the pigeons had learned earlier to push the box, but it wasn't there now during this test. And they watched these pigeons to see whether they'd figure out a way to solve the problem. Would they figure out a way to peck this banana? And what they found was that the pigeons who had been reinforced earlier for pushing the box were able to solve the problem. Not only that, but they also solved it in a way that was very similar to how Kohler's chimps had solved it. They solved it in a very chimpanzee like fashion, is how Epstein and his colleagues put it. So at first, they looked sort of confused, right? They kept looking at the banana, then the box, back and forth like that. So, no solution in sight for a little while. They don't seem like they're getting any closer to solving this problem. But then suddenly, they started pushing the box in the direction of the banana. They started adjusting it as necessary until it was directly underneath the banana. And when it was, they climbed on top of the box and pecked the banana. So, those pigeons, the ones who had previously been reinforced for pushing the box, they were able to solve this problem. However, the pigeons from the other group, the ones who hadn't been trained earlier to push the box, they failed to solve the problem. The researchers gave them 45 minutes to figure it out, but none of them ever did. By contrast, the other pigeons, the ones who had learned in the first phase to push the box, they solved it within about 1 minute. Even though, again, they had never been reinforced specifically for pushing the box in the direction of the banana. So this was a new problem for them, but they figured it out anyway. They solved the problem in a sort of sudden way that's characteristic of insight. And again, the only difference between these groups of pigeons had to do with their previous training. It had to do with their previous histories of reinforcement. So, the conclusion that Epstein and his colleagues drew from these results was that insightful problem solving does depend on an individual's previous learning history. So, it shouldn't be treated as this mysterious phenomenon that's incompatible with operant conditioning. It shouldn't be attributed to the mysterious hocus pocus of the mind, because these and other results suggest that the learning experiences you've had prior to encountering a problem do play a role in your ability to solve that problem, even when the solution seems to appear in that sudden aha sort of way. Okay, so that's all I have to say about insight. Please let me know if you have any questions about this stuff on insight. But, guys, something else that's sometimes been attributed to that mysterious hocus pocus of the mind is creativity, which is also covered in chapter 6 of the textbook. But again, it's possible to explain individual differences in creativity based, at least in part, on operant conditioning. And guys, the basic idea here should sound familiar because you read in chapter 5 that it's possible to reinforce any feature of a behavior. So, for example, a study by Suzanne Page and Alan Nuringer found that even the randomness of a behavior can be strengthened by reinforcement. So, in that study, they had pigeons pecking keys in Skinner boxes. Okay, there were two different keys that the pigeons could peck. And Page and Nuringer reinforced these pigeons for any series of 8 key pecks that was different from each of the 50 series that had occurred before it. So all the pigeons had to do to get the reinforcer, the only requirement for reinforcement was that these pigeons produce a unique series of pecks. They just had to produce a series that they hadn't produced recently. And the results of that study were that the pigeons started pecking these keys in ways that appeared truly random. So the variability of their peck sequences increased because that's the aspect of their behavior that the researchers were reinforcing. So you can increase the variability, you can increase the apparent randomness of a behavior with reinforcement. And a related point is that it's also possible to reinforce novel behavior. And that's important because, as the textbook points out, novelty is an essential feature of any definition of creativity. When you say that someone is being creative, you're saying, among other things, that they're performing these new, original, novel patterns of behavior. And like I said before, it's possible to increase the novelty of an individual's behavior by making it so that reinforcers are contingent upon behaving in new ways. And the textbook provides several examples of this, but one of the most interesting examples, I think, involves the behavior of trained porpoises who are performing tricks for audiences. Now, these porpoises trainer was Karen Pryor, who's a quite famous animal trainer, and she decided that a neat thing to do during her shows would be to let the audience see the porpoises learning new tricks. She thought it'd be cool for them to see the porpoises go through the process of learning a new trick. It made for a well received part of the shows, but it didn't take long before Pryor and her fellow trainers started running out of new tricks to reinforce in these porpoises. So, what they began doing instead was offering the porpoises reinforcers whenever they did anything new. So, again, it didn't matter what the new behavior was, the only requirement for reinforcers was that these porpoises perform novel behaviors. And of course, the reason I'm talking about this is because that plan worked. So, if you want to get an animal to behave in novel ways, all you've got to do is reinforce it when it engages in novel behavior. So, just like you can increase the frequency, the intensity, or the duration of a behavior with reinforcers, you can also increase the novelty of behavior by making reinforcers contingent on new, unique forms of behavior. And of course, the same strategy works in humans too. For example, your book also describes an experiment by Kathy Chambers and her colleagues in which 6 to 8-year-old children built things with blocks. So that's what these kids are doing. They're building things with blocks. But there's two groups of kids. In the experimental group, the children were praised whenever they built anything new. So again, it didn't matter what the new construction was as long as it was different from whatever they had built before. If they made a novel construction like that, then that's when they got praised. Children in the control group built things with blocks too, but they didn't receive any praise for building new things. For those kids, the experimenter just watched them play with the blocks and didn't provide any commentary. And when the researchers looked at the number of novel block configurations that the kids in each group produced, they found almost twice as many in the experimental group as they did in the control group. So even though these kids weren't specifically told that praise was contingent on building new things, the fact that they were reinforced for these novel creative behaviors resulted in a pretty dramatic increase in that type of behavior. So, in other words, the kids didn't have to be directly instructed to be creative. The reinforcing consequences of creative behavior caused them to produce more of it. So, the point is, if you want to increase an individual's creativity, you can shape that aspect of their behavior in very much the same way as you'd shape any other aspect of it. So, as much as we might like to attribute creativity entirely to these mysterious inner workings of the mind, scientific research tells us that operant conditioning is a big part of the story when it comes to why some people are more creative than others. Okay, well, that's going to do it for this video lecture on insight and creativity. And as always, if you have any questions about this stuff, then please do reach out and let me know. Okay, take care, guys.